So the next part of integration we need to look at is looking at the trapezium rule. Now, sometimes finding the exact area under curve is difficult using integration depending on what the function is. Now, some of you will have done the trapezium rule at GCSE, and some of you won't, depends on what exam board you did. The trapezium rule basically gives us a way of approximating the area under a curve. Okay, so what we look at doing is we split our curve into a number of strips. Okay, we use our y values for each point. So if you look at the one I've got on the screen, I've split it into 3 strips. I'll have y values at 0, 1, 0, 1, 2 and 3. And from these, I can develop these strips of width h. Now, the width h has to be the same, okay? So that difference needs to be equal each time. So all the while, h will be exactly the same. So they need to be equal strips. Now, the trapezium rule tells us that we can use this to approximate our area, okay? Now, all we do is we treat them like trapeziums, hence the trapezium rule. So we will just find the area of each trapezium and we can add them together. Now, what we can do is simplify this slightly. So the top one tells us the area of each trapezium. So it's half of the height times by the parallel edges added together. But we can simplify that to give us that formula there. So to find the area of the area under the curve using the trapezium, we will do a half h, lots of y0 plus 2 lots of y1 plus y2, then plus a y3. Okay, now obviously this can carry on as far as you need it to. You can have as many strips as you need to. Basically, the first strip and the last strip stay separate. All the ones in the middle get multiplied by 2 when they're added. Okay, so nothing too challenging with this. It's more a case of substituting in. Sort of things you will be asked is to look at percentage error and that sort of thing as well. So, in general, the area under the curve, obviously we can do it as integration, okay, but we can do the width of each trapezium h, lots of y1 plus 2 lots of y2 to yn minus 1 plus a yn. Shouldn't be anything too challenging with this. Okay, quick example. We're approximating the region bounded by x equals 1 and x equals 3 for the curve y equals x squared. Obviously, it's a really nice simple one. Between x1 and x3, we want 3 equal strips. Therefore, you need to work out how you can split this down. So for this one, I'm going to go for 1, 1.5, 2, 2.5 and 3, because then that will give me strip 1, strip 2, strip 3 and strip 4. Okay, work out the y values of each, so I'll just substitute in. So 1 squared is 1, 1.5 squared is 2.25, 2 squared is 4, so on. So I'll have 6.25 and 9, and then I can sub into my formula at the top. So h, the width of each trapezium is 0.5, so the gap between each of these is 0.5. So I'll go 0.5 over 2, lots of. Now I just use my y values. Okay, so it will be plus lots of 1 plus 2 lots of the middle ones, so 2.25 plus 4 plus 6.25 plus my last one. Straight through your calculators, and we will get approximately 3504 units squared. Okay, now this is an approximation, it is certainly not an exact amount. Okay, so you've just got to be a little bit careful. Okay, just want to show you a couple more examples. So, typical sort of exam question. We can work our way through. We can, you get given a table, you might have to find a missing one. So to find that missing one, all I'm going to do is sub 1.3 into my top part. So it'll be 1.3 over the square root of 1 plus 1.3. Again, just using your calculator, we're going to 4 decimal places. So when we sub that in, we get 0.8572, which can go into that gap. Okay, then use the trapezium rule with all the values of y to obtain the approximate value. So we've got a gap this time of 0.1. So we'll go 0.1 over 2 because that's h, lots of 0.7071 plus 2 lots of the middle one. So 0.7591 plus 0.8090 plus 0.8572 plus 0.9037, and then the last one 0.9487, and again through your calculator that gives you 0.41569, which if we want to 3 decimal places, 0.416 units squared. Okay, nothing difficult about this whatsoever, guys. It's just making sure that we remember the formula. Okay, if you can't remember the formula, if you imagine what the curve is, just work out each time the area of each singular trapezium and you will make your way there. Okay. Last example I want to show you. Okay, typical sort of thing that you'll see. Okay, so we've got to integrate sec x between pi over 3 and 0. Now the first one is find the exact value. If it asks you to find the exact value, you need to integrate properly. Okay, now sec x is one of our standard integral functions from the formula book, so we can go straight to what the integral is. So it will be log natural sec x plus tan x. Okay, straight out of the formula book, that one, between pi over 3 and 0. Sub in and subtract, and we should get to log natural of 2 plus root 3. Okay. Shouldn't be anything too difficult with that. Obviously, they might make this a bit more complicated that you've got to integrate. Use a trapezium rule with 2 strips. Okay, now if I'm going between 0 and pi over 3, if I want 2 strips, I need one equally in the middle, so I'll go pi over 6. So you do have to work out that missing value as well. Work out my y values by subbing in each time. So to sub in 0, I need to do sec of 0. Well, I can't do sec of 0, but what I can do is make that into 1 over cos x and then sub into that. So 1 over cos 0 will give me 1. 1 over cos of pi over 6 gives me 1.55. 1 over cos of pi over 3 will give me 2. Then we can substitute in, so it will be approximately, our gap is pi, so it's pi over 6 lots of a half, because it's h over 2, so pi over 6 lots of a half, so it'll be pi over 12, lots of 1 plus 2 times 1.55, there's only 1 in the middle this time, plus 2, and again through your calculator, and this time we'll get 1.39. Okay, then use trapezium rule with 4 strips. Same idea, you just need to split it up a little bit more. So this time we're going to go 0. We need double the amount of strips, so I need to go in the middle again. So we'll go pi over 12, pi over 6, pi over 4 and pi over 3. Now when you split these up, guys, you can do it so that you keep them all as the same denominator, just to make it easy to split it up for yourself. So if you left them all as an amount over 12, so pi over 12, 2 pi over 12, 3 pi over 12, and 4 pi over 12, that might be easier. That's absolutely fine. We sub in again, so we'll have 1, again use the 1 over cos x instead. So we can have 1, 1.035, 1.155, 1.414, and 2. And again, we sub in to find our value of I. So this time it's going to be pi over 12 times a half, lots of 1 plus 2 lots of 1.035 plus 1.155 plus 1.414 plus a 2 on the end, and we will get approximately 1.34. Now what we should know, guys, if we have more strips, we are going to be more accurate. Okay, so the last part, find the percentage error in using each estimate. Okay, so using estimate 1, okay, we can work out our percentage error. So we will have to do log natural of 2 plus root 3 minus 1.39 over log natural of 2 plus root 3. And that was for part B, and we get 5.5% error. And for the second one, log natural of 2 plus root 3 minus 1.34 over log natural of 2 plus root 3. And that gives us an error of 1.7%. Okay, more strips, more accurate. Really nothing difficult here. It's a nice, easy lesson today. Basically just subbing into a formula. You may have to do a little bit of integrating at the start to help work out the percentage error. Right, I want you to pause the video now. I want you to have a go at this question, and then we will have a look through it, and I'll get you moving on to the next part. So pause, have a go, and we'll have a look at the next bit. Okay, so part A, use trapezium rule to obtain an approximation for R. So we have 1, 2, 3, 4 strips. So our gaps are 0.5. So we will go 0.5 over 2, lots of 2 plus 2 lots of 4.077 plus 7.389 plus 10.043 plus a 0. And this means our answer will be approximately 11.2545, which to the 2 decimal places it asks for will be 11.25. Part B, explain how the trapezium rule can be more accurate. Well, that's using more strips, so smaller intervals. Okay, what it's really looking for is for you to say you need to do more lots of it. You need to be have more parts to it. Part C, use calculus to showing each step in your working to obtain an exact value. So now we've got to actually integrate. Okay, so we need to integrate between 2 and 0, 2 minus x e to the 2x. Okay, right. Back to integration again. A few different ways you can do this. For me, I can see 2 products. I can see there isn't much linking them in terms of a differential. Therefore, I'm going to use integration by parts. Because I'm using integration by parts, I set up a u equaling 2 minus x and a dv dx equaling e to the 2x. I find du dx, which is going to be negative 1. I find v, which is going to be a half e to the 2x, and I can sub into my formula. So uv minus the integral of the 2 new parts we made, so v du dx, which will become, so uv becomes 2 minus x lots of a half e to the 2x, I've just put the half in front just to make it a little bit neater, minus the integral of v du dx, so it becomes minus a half, because we've got minus 1, e to the 2x with respect to x. Just going to tidy up my integral a little bit to make my life a little bit easier. First bit stays the same. I'm going to bring the minus a half out, so it comes plus the integral of e to the 2x dx. Already get integrated e to the 2x up here, so that's nice and simple. So we'll go a half, lots of 2 minus x e to the 2x plus a half e to the 2x plus a half e to the 2x times by, the half, sorry, missed the half out in here, plus a half lots of e to the 2x times a half. So we'll have a half lots of 2 minus x e to the 2x plus a quarter e to the 2x. Obviously, we're doing definite integration, so we'll go square brackets between 2 and 0. When we substitute in, we will end up with a quarter e to the 4, subtract 1 plus a quarter, so final answer, a quarter e to the 4 minus 5/4. Okay. Again, we are going to end up having to do this full integration as well at some point in it. Quite a lot of the time, like the previous example, it does ask you to work out percentage error as well. Please log back onto Show My Homework, have a look at the questions I want you to have a go at.